Alright, hey guys, today we are looking at angles and radian measure. So, to start off, we are going to talk about some things that you should remember from Algebra 1. Quadrants of a coordinate plane. So recall that quadrant 1 is right here, where both the x and y are positive. Quadrant 2, quadrant 3, and quadrant 4. So when we are naming angles in standard position, first off, the vertex is at the origin. And the initial side is on the x-axis. Angles are measured counterclockwise. That's the standard direction that we measure. So for example, if we start here at the origin, there's our initial side. This side is what we call the terminal side. And we would measure that from that x-axis around to that side. All right, so draw the following angles in standard position and name the quadrant. So to draw the angles, we're going to start on the x-axis. So I'm just going to sketch in an xy axis there. So I start here, and a 330 degree angle. Well, I know that every quadrant is 90 degrees. So 90, 180, 270, and then I need to go 60 degrees more than that. So I'm going all the way around here, almost back to where I started. 360 would get me all the way around once. So we are down in quadrant 4. And then a 400 degree angle would be same thing. We start along this axis, but 400 degrees means that I've gone all the way around 360 plus 40 degrees more. So I'm right here. And I'm in quadrant 1. When you see a negative angle, that means instead of us going counterclockwise, we're going to go clockwise that number of degrees. So 120 degrees in the negative direction means we're going to go here. And then 90 would take us one quadrant, or one axis away, and then 30 degrees more. So we're going in this direction, 120, and we end up in quadrant 3. So, note negative 120 degrees and 240 degrees are coterminals. And what that means is if I measure a 240 degree angle in the positive direction, it would end up in the same spot as that negative 120 degree angle that we just drew. Both are in standard position with coinciding terminal sides. So to find coterminals, we add or subtract 360. So what is coterminal to 400 degrees? Well, we can subtract 360, so 40 degrees. We could add 360, so 760 degrees. We can keep adding 360 degrees or subtracting 360 degrees. So like negative 320 degrees would be another example if we subtracted another 360. So those options are infinite there. And so for example 2, it says find one positive and one negative angle that are coterminal to negative 100. So probably the easiest thing to do would just be to subtract 360 and add 360. So I get negative 460 degrees when I subtract 360 from negative 100. If I add 360, I get 260 degrees. 575 degrees, I can get negative 145 degrees, or 215 degrees, or if you really want to keep adding on, 935 degrees. Again, those options are infinite. All right, one thing that we are going to focus a lot on in this chapter is the unit circle. And so we talked about the degree measures of the axes. So this is 0 degrees right here, but also if you make it all the way around, it's 360 degrees. So halfway across is 180 degrees. A quarter of the way is 90 degrees. 3/4 of the way is 270 degrees. So we split up the unit circle into a few more degree measurements, and these are the standard degree measures that you need to know. So the ones right in the middle are half of the 90-degree increments. So this one is 45 degrees. This one is 135 degrees. And then we have 225 degrees and 315 degrees. And you do need to know these, but you probably can do the math to come up with them if you don't have them memorized. The other ones then are splitting your unit circle into, or your quadrants into thirds. So 90 divided by 3 gives us 30. So this is 30 degrees, 60 degrees, then we have 90, and then 120 degrees, 150 degrees, 180, then 210 degrees, and then 240 degrees, 270, 300 degrees, and 330 degrees. So those are the degree measures that you should know, and you will be quizzed over knowing those degree measures. And you'll need these again next year in IB Math 1 or Pre-Calc, whichever you are choosing to take. So then we have another way of dealing with measurements. So it's called radians. 1 radian is the measure of an angle in standard position whose terminal side intercepts an arc of length r. So if this is the radius of the circle, this is r, 1 radian is a measurement of r on the arc length. So this is 1 radian. And we write that shorthand as RAD is how we write radians. So there are approximately 6.28 radians in a full circle, which is 2 pi. So that means, if you look here, 2 pi radians is 360 degrees, which means that pi radians is 180 degrees. So 1 pi is halfway around that unit circle. So then we're going to be able to fill in this unit circle with radians. So we know that we start at 0, and then 1 full rotation is 2 pi. So halfway around is pi, which means 1/4 of the way around is pi over 2. And then 3/4 of the way around is 3 pi over 2. And then we start splitting it up even further. So those middle pieces, then if that's pi over 2, we split that in half again, we get pi over 4. So then we have 1 pi over 4, 2 pi over 4 is pi over 2, 3 pi over 4, and 4 pi over 4 is pi. Then we get 5 pi over 4, and 6 pi over 4 is the same as 3 pi over 2, and then 7 pi over 4. 8 pi over 4 happens to be 2 pi, and we're back around to where we started. Then we have our degree measures that are split up into thirds. So pi over 2 in thirds gives us pi over 6. So we're going by 1/6 every time we go around. So 1 pi over 6, 2 pi over 6 is pi over 3. 3 pi over 6 is pi over 2. 4 pi over 6 is 2 pi over 3. 5 pi over 6. 6 pi over 6 is pi. 7 pi over 6. Then 8 pi over 6 is 4 pi over 3. 9 pi over 6 is 3 pi over 2. 10 pi over 6 is 5 pi over 3. And then we have 11 pi over 6. Again, this is one that you will need to have memorized to be quizzed over and know this next year as well in pre-calculus or IB math. If no units are specified, then radian units are implied. So that means if you don't see it specifically telling you whether you're dealing in degrees or radians, then you are dealing in degrees. Or you are dealing in radians. So one thing you might have to do is convert to radians or convert to degrees from radians. So the conversion factor then is just our matching pieces on the unit circle. So one thing we know is that 1 pi is equal to 180 degrees. So when we convert, we can use pi over 180 or 180 over pi because those are equivalent to each other. So if you think back to Algebra 1 when you did conversions, we want to put the thing on the bottom or the thing in the opposite spot that we're trying to get rid of. So if we want to get rid of degrees, we're going to put 180 degrees on the bottom and we'll put pi on the top. So then we get 135 pi over 180, which reduce that down and we get 3 pi over 4. Negative 270 degrees times pi over 180. We get negative 270 pi over 180, which reduces to negative 3 pi over 2. If you're not sure how to put that in the calculator, I just ignore the pi. Put the negative 270 divided by 180 in your calculator and reduce that fraction, and then bring that pi back along with you to make up that fraction. All right, then we can go the other direction. So to convert to degrees, we want to multiply by 180 over pi. So times 180 over pi. Those pi's will cancel, so we get negative 180 over 2, or negative 90 degrees. Then we have 9 pi over 2, multiply by 180 over pi again. Again, these pi's cancel. So then the 180 and the 2, I can make that 90 over 1. So then my denominator there is just 1. And then I get 9 times 90, which is 810 degrees. And then the last one I have is just 2. So I multiply by 180 over pi. and I get 360 over pi degrees. And we just leave it like that. All right, guys, that's all I have for you today. If you have questions, feel free to come in and see me. Otherwise, I'll see you in class.